Where do you land a plane in a place that's run out of space? Japan's answer, Kansai International Airport, a floating megastructure built to withstand the wrath of Mother Nature up above. But what about down below? Fasten your seatbelts and prepare for takeoff to an amazing island airport in the land of the rising sun that may be destined to sink back into the sea. This is Osaka, the ancient capital of Japan, and former playground for the last samurai, now conquered by a generation that dances to the beat of their own drum. Home to 2.6 million people, a new energy in Osaka has propelled this place to become the commercial and industrial center of Western Japan. But in order to compete with their big sister Tokyo, Osaka needed to find a way to bring in more people, with a yen for big business. Their answer? A much bigger airport to open up the skies. But government officials wrestled with a question of sumo proportion. Exactly where do you put a new airport large enough to meet demands of the day, without the noise pollution that has spoiled many a backyard gathering? Let's not forget, Japan's an island the size of California, and this area is partially mountainous and so heavily populated that trying to find a big, flat slab of open land in Osaka is like trying to negotiate armrest space on a crowded 747. So instead of moving mountains, officials decided to climb one, creating a plan to build an airport unlike any other. Their earth-shattering decision? If there's no room to land planes on shore, why not have them land offshore, on another island? Only thing is, they had to build it first. In 1987, construction of the world's biggest man-made island of its time broke ground, or water, 18 meters deep in the middle of Osaka Bay. 7 years later, the world had its first international airport floating out in the middle of the sea all by itself. A true oasis for pilots.
It's like a jewel in a black hole. It's fabulous when you see the lights. Not because, oh my gosh, there it is, but it's really beautiful.
It's actually quite nice because there's no obstacles. It's out in the middle, so out in the middle of the water, so you don't have to worry about hitting anything coming in.
Well, anything except the runway. It's Kansai International Airport, now one of Japan's busiest air hubs, handling more than 300,000 passengers a week, open 24 hours a day. Recognized by the world as one of the most incredible engineering marvels of the 20th century, and compared to megastructures like the Hoover Dam and the Panama Canal, Kansai was built 5 kilometers from shore and contains 530 hectares of landfill, making a massive rectangle that's more than 4 kilometers long and 1,200 meters wide. That's big enough to swallow up the entire downtown area of Osaka. Connected to the mainland by the world's longest two-tiered bridge, Kansai welcomes 55,000 planes a year, a unique experience for both pilots and passengers, making what appears to be a liquid landing.
The water always looks much closer as you're diving down into the airport, and so yeah, that's pretty scary.
Building this black hole airport created a real-life parting of the seas and truly was a construction project of biblical proportions. It's the largest public works undertaking of the 20th century, costing a total of $15 billion US, with over 1 million workers putting in 10 million hours of manpower. To pave the way for the textbook landings of today, Japanese engineers had to rewrite the manual on how to build an airport. Kansai airport planner Yasunari Harada has been there since takeoff.
The biggest challenge was to supervise the entire construction and open the airport as scheduled. It was a balance between the engineering for the landfill and the construction on top of that.
And speaking of balance, there was one little problem. Exactly how would the artificial island hold up to all the pressures from above without collapsing into the spongy seabed below? Never before had anyone attempted a massive landfill project, so far from shore and so deep in the water. Both would pose potential problems. Engineering manager Shinya Suzuki.
There is a deposit of clay at the bottom of the sea. It's a layer of very soft clay, and if it keeps sinking after the construction, that could cause some problems for the airport.
Okay, so the bottom of Osaka Bay is made of soft, spongy clay that's likely to sink. Not really the kind of stuff you want to top off with an airport runway. That's more like landing a 360 metric ton jumbo jet on a huge plate of tofu. To solve the squishy problem, Kansai's engineers turned to a new sand draining technique to actually speed up the sinking by sucking the water out of the sand and shoring up the airport's foundation. Confident in their techniques, Kansai engineers set aside any of their own sinking feelings and moved onward and upward with a plan to beat the sinking by throwing several extra feet of fill on top for good measure. And with that, the 6-year process began. First, an 11-kilometer seawall of concrete blocks outlined the shape of things to come. Think of it as building the lip around the edge of a swimming pool, only this immense enclosure keeps the water on the outside. Then, 80 barges ploughed in, dumping 180 million cubic meters of landfill inside the sea wall. That's enough to build the Great Pyramid of Giza 70 times over. Using the technology of the time, builders monitored and measured the layering of the land, making sure the fill was compacting at an even rate to prevent uneven sinking. And just as the face of the island started to pop out of the water, construction began simultaneously on 2 major airport landmarks. Kansai's passenger terminal proved to be an architectural conundrum that stumped even the best builders. The terminal had to be light enough to keep settling to a minimum, but what kind of fat-free materials would be strong enough to withstand Mother Nature's frequent visits, bringing typhoons and earthquakes to the area? Enter world-renowned architect Renzo Piano, the guy who gave us France's controversial Pompidou Center. You know, that brightly colored building with the insides on the outside. Piano proposed a design that would keep everybody at Kansai happy: engineers, builders, and pooped-out passengers at the gate. His baby? A wing-shaped terminal made of steel and reinforced glass. Exactly 1 mile long, Kansai's signature structure is one of the largest single-room buildings in the world. The next crucial challenge in completing this airport was the ultimate question of access. If you stick an airport out in the middle of the water, how on earth do you get delivery trucks packed with peanuts and minivans loaded with luggage in and out efficiently? The answer came along with the construction of the Skygate Bridge. With the use of floating cranes, workers built each of the bridge's piers one at a time, cementing the pieces together like giant toy building blocks. Today, it's the world's longest double-decker truss bridge. At 3,750 meters long, it carries 6 lanes of traffic on top and 2 trains below. Just high enough for boats to pass under, yet low enough for jets to fly over. Finally, after 7 long years of drilling, dumping and designing on what seemed to be a wing and a prayer, this aerodynamic airport opened for business on September the 4th, 1994. And in the first month alone, 10,000 people a day came to the airport, and they weren't going anywhere. They just wanted to witness the pie-in-the-sky plan that finally became a reality.
We were very anxious to see if it would all work perfectly here. I was so excited when the first flight flew in and everything worked.
A million workers, over 200 million metric tons of materials, 10 million hours of hard labor, reclaiming the sea and opening up the skies to a bright future coming in for a landing.
I have nothing but admiration for what they've provided for us there.
When the dust from this massive construction project finally settled, word began to spread that something else did too.
So the airport was sinking, the islands dropping into the water.
And dropping a little faster than planners had planned. During construction, the sand draining appeared to take care of strengthening the bay's first level of soft soil, helping to accelerate any potential sinking. But it would be the deeper stuff, the soil they couldn't drain, that would soon become a problem. That deeper stuff is called diluvium soil. Because there weren't any published reports about how that type of soil settles on the bottom of the sea, engineers had to try to estimate the degree of settling that would occur. By 1999, on Kansai's 5th birthday, it became apparent that the guesstimating was way off, as the entire island had already sunk over 8 meters, aging the airport 40 years ahead of schedule. The two major questions officials had to be asking themselves: would the sinking stop there? And what does all this business down below mean for the structures up above? Deep in the bowels of the high-tech terminal lies a somewhat low-tech solution to try and win the battle between Mother Nature and Father Time. To help save the structure from splitting at the seams, cracking under the pressure caused by uneven settling, engineers give a little lift to the 900 giant support columns that hold the terminal building up. It's a simple system you'll understand if you've ever changed a flat tire before. First, each column is equipped with a sensor that's connected to a computerized system. When the island shifts, the system signals where the power lifting must take place, and technicians rush in. Next, hydraulic jacks, each capable of lifting 300 tons, are inserted between the floor and the column in question. Then, the huge support is lifted and metal plates are added, one at a time, to raise the height of the upper floors back to level once again. It's a delicate game of balance that's a little like sliding a book of matches underneath a wobbly table to keep your sake from spilling. When this jacking up procedure is done, the basement floor remains at the same level, while the first floor moves up. But when you raise the roof on a 2.7 million metric ton building, things in the basement might start to look a little strange. So steps were taken to keep things on the up and up, literally. For example, double walls were installed that hang from the first floor. When the floor is jacked up, the walls follow suit. Also in the basement, air conditioning ducts are bolted to the ceiling, not the floors, keeping wires and hoses from pulling apart as the building grows. Staircases from the first floor get an extra step or two added to the bottom. And on the first floor, passengers are probably not even aware these metal plates at the bottom of each escalator keeps them from tripping on the trippy change in levels. But just how long can this terminal continue to be propped up, defying the laws of gravity? If the whole island keeps getting lower, is the basement only one typhoon away from waves crashing in? According to Kansai officials, the soil settling is slowing down significantly. In turn, that means the uneven sinking is becoming much less frequent. In fact, airport engineers say the sinking has slowed to just 5 centimeters a year, as opposed to the 5 centimeters a month it declined during construction.
I believe that we've solved the problem, but you never know until it's done.
So the airport won't go down without a fight, even if Sir Isaac Newton may be in the other corner. But if the uneven settling isn't settled and continues to mess with the airport's foundation, forget about the buildings, what about the runway? Without it, there is no airport.
Since it's settling evenly, the entire runway is getting lower. But it's not a problem as long as it's flat. It's settling evenly and keeping the same angle, which is what matters. No problem at all.
It's not sinking that fast. So, you know, they'll have the other runway up before this one's underwater. I'm not worried.
And so the secret's out. The Kansai engineering team is so confident in their triumph over the ocean, they're actually at it again, building a second island with a second runway. But before that fantasy island becomes a reality, how do passengers feel about the possibility of this runway being pulled out from underneath them?
We think we're confident in Japanese engineers that they'd have all that covered.
We're more concerned about, I think, earthquakes than the island actually sinking. And from what I hear, like all these it's structurally designed to prevent any major damage from earthquakes.
And actually, he's right. As if they weren't already on shaky ground, Kansai sits in the middle of that volatile vortex of natural disasters called the Pacific Rim of Fire, home to earthquakes, tidal waves, and some of the worst weather on the planet.
We have frequent typhoons and earthquakes in this country. Those factors were taken fully into consideration during the design phase.
And it's a good thing too, because in 1995, with the airport only open for 15 months, an earthquake measuring 7.2 on the Richter scale hit the nearby city of Kobe, the epicenter just 29 kilometers from the airport island.
We didn't have any glass damaged by the earthquake. We found some small cracks, but not the slightest bit of severe damage.
While the city of Kobe was devastated, the advanced structural design of Kansai's terminal building stood strong, perhaps proving to Kansai critics that all those ground preparations and propping up procedures might also be enough to keep the sinking at bay. One giant room with a view and one smart design. The windows are all held in place with flexible joints to stand strong when Mother Nature comes knocking. Every year, the Kansai region gets pounded by giant tropical typhoons that can generate winds up to 190 miles per hour, bringing along damaging high tides, not good for an airport surrounded by water that happens to be sinking. On a gusty day, this unprotected island can give pilots a run for their money. United Airlines captain Richard Earhart commands a Boeing 777 to Kansai on a regular basis.
When you put an airport in a bay like this, you're going to get winds that vary. As we came down, we had winds that were like 20, they'd be 20 knots off our right wing, and then there'd be maybe up by the nose, 8 or 10 knots, and then coming back in the rear, maybe all of a sudden it's a quartering tail when 19 knots.
The varying winds beneath their wings keep pilots on their toes and the weather and traffic controllers on their feet. But while turbulent weather is always on the radar here at Kansai, safety is too, and everyone proudly plays a part in that, from the tower to the tarmac. In 2004, Kansai International Airport celebrates its 10th year of operation as Japan's new portal to the Pacific, welcoming travelers from around the world. And while 10 years is still considered a kid compared to its older airport siblings like Heathrow and JFK, this artificial horizon may already be experiencing some growing pains that could be a bit premature.
Well, we handle the departure and arrivals with a single runway, so that causes this delay. But once you have the second runway, you will use the one runway for arrivals exclusively.
It's simple maths. If you double the runways, you double the number of flights. And bringing in 60 jets an hour instead of 30 also means doubling airport revenues. And so that brings us back to the beginning. Sort of a deep water déjà vu, because a new runway meant building a new island out in the middle of Osaka Bay. Plans for this parallel runway called for a longer landing strip, 500 meters longer than the first, allowing bigger jumbo jets more of a comfort zone for taking off and landing. Located only 200 meters from the first island, this mammoth construction project was in one way old hat for engineers, relying upon lessons learned the first time around. The birth of this new island brought up some issues that no one had notes on. First, the fact that the island was being built even farther out from the mainland. Then, deeper water meant softer soil under the seabed, possibly causing this island to sink nearly 6 meters more than its neighbor. And finally, a new worry. Would the additional weight of the second island affect the level of the first, possibly causing it to sink even further?
We came up with the idea to build the second island 200 meters away from the first one to prevent the weight effect on the old island.
One of the biggest challenges in building the first island was the even distribution of the landfill. Not enough here, too much there, could mean an uneven rate of settling. And with an even bigger island, evening out 250 million cubic meters of mountain sand was like climbing Mount Fuji. But in the 12 years since the first large barge dumped its dirt, technology had improved, propelling the landfill positioning from simple radio waves to global satellites, making landfill less of a guessing game. Each half-meter layer of topsoil is placed and pounded by heavy machinery, tricked out with GPS systems that allow information on position and height to be monitored. Operators on these special computer-equipped dune buggies then get the lay of the land and can tell immediately if they're right on target or missing their mark.
We used to take physical measurements for the positioning of barges in the planning of the landfill process, but I believe the new satellite technology offers more accuracy and precision.
But even the most accurate and precise technology couldn't keep Mother Nature from stepping in and slowing things down, reminding the people on this colossal construction site to respect another kind of flight. Construction on a few patches of land on Phase 2 has been temporarily halted as a species of migratory bird, the kawahisashi, decided to fly in for a layover on their way to Australia. Guess they weren't too concerned about these guys. Keeping in line with Kansai's environmentally friendly face, airport officials decided not to sacrifice something precious for their plan, and have left these few sacred squares to be completed after the eggs hatch and the birds are cleared for takeoff. With all the excitement and activity on the new island, it's almost easy to forget they're doing this just 200 meters away from giant jets packed with people coming in for a landing, which brings up another engineering challenge yet to be tested. Exactly how do you connect the two islands if they're sinking at different speeds?
The new island will still be gradually settling after the opening, but eventually it will be at the same level with the first one.
The decision to expand Kansai was made during brighter economic times in Japan and long before the technology slowdown in the United States. So raising capital for a new addition while still paying off debt from the first was almost as difficult as raising an airport out of the sea.
I believe this will be a great airport in 10 or 20 years when the demand increases with a lot more airplanes flying in and out.
Despite enthusiastic passengers who cried Banzai for Kansai and brilliant engineering efforts fighting the forces of physics, will the weight of everything else prove to be too much to survive? Sinking Kansai under the burden of huge debts and a bad economy? Only time, and maybe the tides, will tell.